Hey everyone, how's things going? This is section 6.3, the properties of a trigonomical function. And let's go and get started. The first thing we're going to do is determine the range and the domain of a trig function. We could go through and try to mathematically look at each one and figure out what the range and domains are just by putting in the calculation values. But I'm going to go and jump ahead, because all of these are actually defined for us. And what it says is that the domain of a sine and a cosine function are the set of all real numbers. We also say that the domain of the tangent function is the set of all real numbers except for odd multiples of pi over 2. Same falls for the secant function. And then we also said the domain of cotangent functions is all real numbers except for the integers of pi. And then the cosecant function is a set of real numbers except for integers multiples of pi. Now, we defined that the range of sine and cosine are based upon its axis. So in this case, we can say that -1 is less than or equal to sine, or sine is less than and equal to 1. Same is true about the other functions as well. The only one that isn't that way is the tangent, because we can go from -infinity to positive infinity. And same thing with cotangent. If you ever need to, you have the list right here of all the different functions. How important is this to memorize? Well, this is more a knowledge-based set where you can go through and look and try to memorize these charts, but in reality is that you will work with it and so much that you'll have this memorized within a short period of time. So don't stress over it. So let's go and look at the first one. Determine the period of a trigonometric function. Now, as you can see here, we have a function. We have half pi over the square root of 3. I'm going to go ahead and switch to my camera because I'm going to draw something out here. If I have 7 pi over 3, and I want to do it on a unit circle. First thing I'm going to do is I'm going to write my unit circle. We know that 3 goes around, start here. We get to here, we're at 3 pi, correct? Get over here, we're at 6 pi. How did I know from here to here was 3 pi? Well, we know that the full rotation is 2 pi. Therefore, for me to make one full revolution, this would have to equal 6 pi over 3. What am I left with? I'm left with pi over 3. Now, I could take this value, 7 pi over 3, and write it in two different ways. I could write it as 7 pi over 3, or I could write it as pi over 3 plus 2 pi. 2 pi because I went around the circle one full revolution, and I have a remain of pi over 3. Once I do that, I can actually now go and solve my different trig functions, correct? Because I can solve for cosine, sine, tangent, because what is pi over 3? And if you don't remember what pi over 3 is, it's okay. You can go to your unit circle here. Pi over 3 is your 60 degrees, which gives you 1/2 and the square root of 3 over 2. Okay. I can solve all my 6 quadrants now at this point. Now here they're giving you the same kind of formula that I did before. You had your theta plus the number of rotations of 2 pi. K is the integer for the number of rotations. So in our case, it went around 1 rotation, so it would be 2 pi times 1. Okay. And this is what they define as the periodic function. They define it as theta plus p is equal to just f of theta. So let's take a look at a couple examples. We first have sine of 17 pi over 4. What quadrant am I in? Well, I don't know for sure, right? But I do know that if I go 4 times 4, it's 16. So, well, let me rewrite this. Because I can say now, sine 16 minus 1 is pi plus 2 pi times 2, because it's how many times we went around. Is the same as saying sine of pi over 4 Of course, I'm going to draw this out so you can actually see how this works. We started here. We went, that's 4 pi over 4, 8 pi over 4, my next rotation, 12 pi over 4, (16 pi over 4), and then I come up 4 pi over 4. And that is my angle there. What is sine pi over 4? Well, if you look at your unit circle, you would see that that is equal to the square root of 2 over 2, and that is your solution. The next one was cosine of 5 pi. Again, draw your unit circle. We start off here at 0. There's pi. We're now at 2 pi. Three pi, 4 pi, and finally we are at 5 pi. 5 pi of cosine is equal to -1. And finally, we have tangent. We have a tangent of 5 pi over 4. Again, draw my crosshairs. We know if I go this way, I'm at 4 pi over 4. And I'm left with a pi over 4, which is 45 degrees. Okay. What do we know pi of 45 degrees of tangent? Well, we know that the tangent is equal to sine over cosine. In this case, 45 degree angle, it is the square root of 2 over 2 over the square root of 2 over 2, which is equal to 1. Let's take a look and see how well we did. Not too shabby. Determine the sign of a trigonometric function in a given quadrant. So we're going to evaluate this based off the signs of the locations. Now, one of the things that I like to do is, because this can get a little confusing trying to memorize all these, I'm going to give you a saying. And that saying is all science teachers are crazy. Again, all science teachers are crazy. So what does that really mean? It means that in quadrant 1, all the values of the trig functions are positive. When I go to quadrant 2, only the signs return back a positive value, meaning sine and then the reciprocal. Same thing with tangent, and then in the final quadrant you get cosine. So each one of the trig functions has a positive location in 2 different points. For sine, it can exist in quadrant 1 and 2. For tangent, it can exist in quadrants 1 and 3. Cosine can exist in quadrants 1 and 4. And let's go and take a look at an example. If we have sine of theta is greater than 0 and cosine of theta is less than 0, name the quadrant in which it lies. So let's start off with the first one. First thing we do is we write it out. Sine of theta is greater than 0. Then we also have cosine of theta, which is less than 0. Well, we know the 2 quadrants for sine are positive in which locations? I'm going to write it up. All science teachers are crazy. So where sine is greater than 0 is in quadrants 1 or 2. Now we need to evaluate where is cosine less than 0. Well, what do we know? Cosine is positive in quadrants 1 and 4. Now, for cosine, what do we know? We know that the angle has to be less than 0. Well, what is cosine on the axis? We know that cosine is our x, right? Values. And our sine is our y values. So if this has to be less than 0, then we know that we must exist either in quadrant 2 or quadrant 3 to meet the needs of cosine being less than 0, or x less than 0. With that being said, there's only one location in which both exist, and that is in quadrant 2. So therefore, this angle must lie in quadrant 2 somewhere. Okay? Find the values of a trig function using the fundamental identities. Now, the fundamental identities we've already talked about a little bit. If you go to your sheet here, I've given you the trig function identities. You have the tangent, sine over cosine. Cotangent is cosine over sine. The reciprocal identities, and the Pythagorean identities. These are the only identities that you're allowed to use for this section when it comes to solving these kind of equations. Okay? So let's go back and take a look. We have the reciprocal identities, the quotient identities, and we have an example. Now, the first example says we have a sine of theta equals the square root of 10 over 10. Then we also have a cosine of theta, which is equal to 3 square root of 10 over 10. Now to solve this, it's kind of nice. It's pretty straightforward because what do we know already? We've got sine, cosine. We need to come up with the other 4. We know tangent is equal to square root of 10 over 10 divided by 3 square root of 10 over 10. This is really nice for us because when I write this out, inverse and multiply, square root of 10 over 10 times 3 square root of 10 over 10. This 10 cancels out that 10. Square root of 10 cancels out there. And what am I left with? I'm left with 1/3. I have a cotangent of theta, which is equal to 1 over tangent. And in this case, 1 over tangent is equal to 1 over 1/3, which is equal to 3. Cosecant is equal to 1 over sine. What was my sine? The square root of 10 over 10. So what am I actually left with? 10 over square root of 10. Multiply times square root of 10. The reason why is because I want to get rid of the radical from the bottom. And what am I left with? I'm left with 10 square root of 10 over 10. 10's cancel out, so therefore I am left with the square root of 10. And last but not least, we have secant of theta, and in this case it's 1 over cosine 3 square root of 10 over 10. We're going to rewrite this equals to 10 over 3 times the square root of 10. Multiply this both sides by square root of 10. This cancels out. What am I left with? I'm equal to 10 square root of 10 over 3. And hopefully that makes sense. Now we've talked about a unit circle. Now we have a unit circle. The theorem was a squared plus b squared equals 1, referring to the number of rotations around it. We've also said that we can replace x and y with sine and cosine. So therefore sine squared plus cosine squared equals 1 is a very valid function. We can also say that sine squared over cosine squared plus 1 is equal to 1 over the cosine squared. Therefore, that equates to tangent theta. So we can also say that sine squared of theta over cosine of theta plus 1 is equal to 1 over cosine squared theta, or basically tangent theta squared plus 1 is equal to secant squared. Same is true about cotangent. It's cosine or cosecant. So you have those three basic fundamental identities for the Pythagorean. You have your inverse identities, and then you also have your relational ones. So let's go and find the exact value of each of the expressions. Do not use a calculator. Well, let's take a look at this. What do we know so far for A? For A, we can say that we have the equation of 1 over cosecant squared of 35 degrees plus cosine squared of 35 degrees. So how are we going to solve this? Well, the first thing I know when I look at or think about my identities is we have one identity that says cosecant squared of theta is equal to 1 over the sine of theta. Sorry, finger pop. With that being said, let me rewrite this equation. I can rewrite this as sine squared of 35 degrees plus cosine squared of 35 degrees. What does this equal? Well, again, we had another identity that said sine squared of theta plus cosine squared of theta equaled 1. In this example, our answer is equal to 1. Let you absorb that for a little bit. Let's go and take a look at the second one. The second one that we have is given in the following form. We have cosine of pi over 3 over sine of pi over 3 minus cotangent of pi over 3. Since my values are all the same, I'm going to do what they call a substitution. I'm just going to write a little note here to myself. I'm going to say let pi over 3 equal j. You can give it any letter you want, it doesn't matter. And what I want to do is I just want to get rid of all of this fractions over more fractions. Make it look nicer. So I can rewrite this as cosine of j over sine of j minus cotangent of j. Well, what do I know already? I know that cotangent is equal to cosine over sine. So can't I just replace this with cotangent? If you said yes, you are correct. So cotangent of j minus cotangent of j equals 0. I can go back and write this the same way as I did before up here, is equal to pi over 3 minus cotangent of pi over 3. Okay. Either way I look at this, it's still going to equal to 0. And there we go. So we're going to take a look at the next section. Find the exact values of a trig function of an angle given one of the functions of the quadrant of an angle. So here we're given sine of 2 over 5. We're also given the cosine of theta is less than 0. And we need to find the exact value for each of the 5 trig functions. So let's jump on our graph, or drawing here. The first thing I'm going to do is we're going to sine of theta is equal to 2 over 5. And we also know that cosine of theta is less than 0. Now, with that information given right now, what quadrant am I in? Well, we know that the x quadrant of cosine of less than 0 is either in quadrants 2 and 3. So we know that this is going to exist in quadrants 2 or 3. What quadrants is sine positive? We know that sine's positive in quadrants 1 or 2. It looks like, in this case, this is being identified as being located in quadrant 2. We're going to draw that out now. And I'm going to come out here. I have an arc that comes like this. We're going to call that theta. I know this may or may not be on your sheet, so I haven't had a chance to look. I just now thought about it. But if it's not, it's okay. We'll just go ahead and cover it real quick right now. We know that cosine of an angle is equal to x over r. And I know I talked about this. We've also said that tangent of an angle is also equal to y over x, and then also that sine of an angle is equal to y over r. So in this case here, we have sine theta 2 of 5. Go ahead and write this out. So we have an x, because we don't know what x is, but we do know what our y is. Our y in this case is equal to 2. We know what our r is, because that's equal to 5. And what we don't know is what our x value is right here. So we need to figure this out. Well, we can use the Pythagorean theorem to figure this out. And it states that we have r is equal to the square root of x squared plus y squared, or x is equal to the square root of r squared minus x squared, y squared. Y is equal to the square root of r squared minus x squared. So these are the three possibilities that you have from the Pythagorean theorem to solve for these different locations. Now, the one we need is x. So we have r squared. In this case, r is equal to 5. We have 5 squared minus my y. My y in this case is 2. Go ahead and break it down even further. 5 squared is 25 minus 4, which is equal to the square root of 21. This is my x value. So now I know that this right here is equal to the square root of 21. We need to be careful because we're doing a square root. It's either positive or negative. Now, based upon where we're at in this unit circle, in the unit, we're in quadrant 2. Therefore, we are negative because my x is negative. Positive, negative. It leaves me negative 21. Okay. The next piece that I want to solve is cosine. So we say that cosine of theta is equal to x over r, which is equal to negative square root of 21 over 5. So now we have sine, we have cosine. Let's go ahead and solve for tangent. We have tangent is equal to 2 over negative square root of 21, which is equal to the negative 2 square root 21 over 21. Now, for those of you who caught on, I just went ahead and did the multiplication of the radical. I'm to the point now that I think you guys have seen it enough times where I can just make that jump. If it confuses you, please let me know, and I'll try to make sure that I make a point out that that's what I did verbally. I just don't want to do all the math that way. Okay? We have cotangent, which is equal to 1 over minus 2 square root of 21 over 21. Again, this is equal to the negative square root of 21 over 2. And then last but not least, secant, which is equal to r over x. In this case is equal to the square root of 5, is equal to negative 5 over the square root of 21. Go ahead and solve. Remove the radical from the bottom. We have a negative 5 square root of 21 over 21. And that is my final solution for all 6 trig functions. So we identified quadrant 2. We identified the x value, and then we went ahead and figured out the additional quad functions. Now we're given the value that sine theta is equal to 2 over 5, and we have an angle that is an acute angle, and then we want to find the exact values for each of the following remaining 5 trig functions. What we're going to do is we're going to start off with one of the identities that we have. We know that we have a sine of theta that equals 2 over 5. We also know that we have an angle that's acute. Okay. So as I look at my trig function identity sheet here, I have sine of theta and then I have nothing else. But if I look at my Pythagorean theorems identities, I see that I can use a sine squared plus cosine squared equals 1. Why? Because I have my sine squared, I have a solid integer of 1, I can solve for my cosine. So let's go and use that. So sine squared of theta plus cosine squared theta equals 1. I'm going to rewrite this because I want to solve for cosine of theta equals 1 minus sine squared theta Again, we have 1 minus, I'm going to plug and chug, got 2 to the 5th. Of course, this is squared. Write it out, so we got 1 minus 4 over 25. I want to go ahead and put this in a fraction form, so 25 over 25. Minus 4 over 25, and this is equal to 21 over 25. And that is equal to, oops, sorry about that. That is equal to my cosine of squared theta. Now I need to get rid of this, so I'm going to take the square root of this, take the square root of this entire thing, and I'm left with cosine of theta is equal to the square root of 21 over the square root of 25. Can this be reduced? No. What about underneath? Yes. And what does it come out to be? Square root of 21 over 5. Now the next important part that I need to look at is where is this at? Where is this located? Do we really know at this point? Oh yeah, we kind of do now. Because we know that sine of theta of 2 over 5, sine of theta 2 over 5 is positive. And in this case, so it's in either quadrants 1 or 2. Okay. An acute angle is more like almost like a 90-degree angle, right? So this could only exist in quadrant 2. Therefore, this value here is negative. So now we've got cosine, we've got sine. Now we can solve for tangent. We know that tangent is equal to the sine over cosine, and in this case it is equal to 2 over the 5 times, we know this is equal to 2 divided by 5 over the square root of 21 negative over 5. We write this out. Negative 5 over the square root of 21. Solve this out. We have a negative 2 square root of 21 over 21. We also now know that cotangent is equal to 1 over tangent, which is equal to the square root of 21 negative over 2. Cosecant of theta is equal to 1 over sine. And we solved 1 over sine earlier. I should say that was given to us. It was given us as 2 over 5. So it's 5 over 2. And last but not least, we have secant. And secant is 1 over cosine. And in this case, cosine was equal to the 1 over the square root of 21 over 5 negative. And if we solve this out, it becomes 5 over the square root of 21 negative. Therefore, this is equal to negative 5 square root of 21 over 21. Let's see how well we did. Does not look too bad. Looks like we got everything there. Okay. Let's go to the next slide. Now, what this is talking about here, finding the values of a trig function, this is just basically the step-by-step process that we just went through. What we do, we drew up the rectangular quadrants. We identified what quadrant it was in. Then we solve r, or if we needed to solve for x or y, we solve for that. And then we went ahead and looked at our identity sheet to see which ones that we had at least 2 of the 3 items available. We solve for it, and then we plug and chug for the other remaining 5 options. So let's go ahead and look at this example here. We have the example of cotangent of 1/3 and the sine of theta is less than 0. So first thing I'm going to think about is what quadrant am I in? I know it popped up there. What quadrant am I in? Okay, I'll draw this off a little bit. We have the cotangent of theta, which is 1/3. And we know that sine of theta is less than 0. Since we know that the cotangent of theta of 1/3 is greater than 0, we have to be in at least quadrant 1. Since we know that we're in cotangent and we're at a positive 1/3, we know that if we drew our triangle, we know if we drew our coordinate system. Remember, all science teachers are crazy. We know that we're positive only in areas 1 and 3, but we have a sine of theta that's less than 0, so it's all above 1 here, but it only is less than 0 in this location. So with that being said, we know that it exists here in quadrant 3. If I were to draw the circle out, what do we already know? We have cosine of 1/3, and because it's in a negative negative, we're going to say that this is at points -1, -3, So now what is my sine of theta? Well, the first thing I need to do is I need to find out what my r is. I don't know what r is. I do know what my x is. I know what my y is. So how am I going to solve for r? Well, like we've said before, you're going to have r squared, or even better yet, let's just say r, is equal to the square root of x squared plus y squared, which is equal to square root of -1 squared plus -3 squared. So we have 1 plus 9, which is equal to 10. We can use the formulas now that the cosine of theta is equal to x over r. In this case, it's -1 over the square root of 10, or it's negative square root of 10 over 10. Next, I have my sine. Sine of theta is equal to y over r, negative 3. Oops. We have negative 3 divided by r. My r in this case is the square root of 10. Need to go ahead and solve for that. Multiply both sides by the radical. We have a negative 3 over 10 over 10. What else could we do? We have tangent. We can say we've got tangent is y over x. In this case, we have a negative 3 over a negative 1, which is equal to 3. We have a secant, theta, which is equal to r over x, which is equal to the square root of 10 over minus 1. Therefore, it's just minus the square root of 10. And then last but not least, cosecant. My cosecant is equal to r over y, which is equal to the negative of the square root of 10 over 3. And there we go. Let's make sure we got everything correct. Looks good. Now I'm going to go ahead and let you walk through this one because it's very similar to the one that we just did. No need to do another example of the same stuff because I will be doing some of the homework problems. So try this one on your own. Use even/odd properties to find exact values of a trig function. Well, in this case here, all we're doing is we're changing the way the actual look of the equation. As you can see, we have a sine of a negative angle is equal to the negative sine of an angle. All we're doing is pulling the negative sign out from within inside the brackets. So our first example, cosine of 60 degrees. We have the cosine of 60 degrees, and it's negative. I'm just going to rewrite this as negative cosine of 60 degrees. If I look on my chart, cosine of 60 degrees is what? Come down here. 60 degrees, cosine, 1/2. The second one was sine of a negative 390 degrees. Well, the first thing I'm going to do is take my 390 degrees, and I'm going to subtract 360 degrees. I'm going to be left with 30 degrees. So I can go ahead and rewrite this as sine of negative 30 degrees is equal to the negative sine of 30 degrees. What is sine of 30 degrees? Again, go to your chart real quick. Sine of 30 degrees, come over to 30 degrees, is half, which is equal to the negative square root of 3 over 2. And last but not least, we have tangent. The tangent is that of a negative 37 pi over 4. We can also say that this is equal to a negative tangent of 37 pi over 4, which we're going to rewrite it again, is equal to a negative tangent of pi over 4 plus 36 over 4. When we write this for the last time, we have a negative tangent of pi over 4. And what are we left with? Negative 1. That's all there is to this section. I look forward to talking to you in the next video.